Hello, everyone. It's a pleasure to welcome you all to yet another insightful session of the Glass Academy webinars in collaboration with Ethos Empowers. We are back with another insightful session in our ongoing journey to explore how glass, sustainability, and smart architecture intersect. Today's session is titled Integration of Glass in Sustainable Facade Design, a GRIHA Perspective. We'll be exploring how the right use of glass can help architects not only create striking, high performance facades, but also meet the environmental benchmarks set by rating systems like GRIHA. From energy optimization to glare control, from daylighting to material selection, this talk unpacks the critical role that glass plays in shaping sustainable buildings, especially from a green certification point of view. To lead this conversation, we are delighted to welcome Mr. Ankit Bhalla, a passionate sustainability expert, educator, and current technical manager at GRIHA Council, Terry. With over a decade of experience in the green building sector, Ankit has played a pivotal role in the evolution and technical development of various GRIHA rating systems and actively contributed to product evaluations, site audits, and industry training initiatives. His academic accolades include a master's from CEPT University, several national awards, including the Terry Roll of Honor and the Bhavan Fellowship supported by the Indo US Science and Technology Forum, and he is currently pursuing his PhD in energy efficiency from IIT Roorkee. Without further delay, let's welcome Mr. Ankit Bhalla and get ready to decode how smart glass integration can help us design facades that are sustainable, sensible, and future ready. Sir, you've had quite a journey from being an architecture graduate at Jamia Millia Islamia to becoming a leading technical voice at GRIHA Council. Could you share a bit about your path and what led you to focus on energy efficiency and sustainability?
Actually, my journey into the field of sustainability and energy efficiency has been both academically enriched and professionally, profound. I began my architectural education at Jamia Millia, where I developed a solid foundation in spatial design and contextual thinking. However, it was during my postgraduate studies at CEPT University in Ahmedabad in the field of energy efficiency and sustainability that my interest in the environmental performance of building became more focused and technically grounded. The program offered a comprehensive understanding of climate responsive design, building physics, and simulation based evaluations, allowing me to approach buildings as integrated systems that interact continuously with their environment. This refined perspective motivated me to engage in roles where research and implementation intersects. At GRIHA Council, I have been contributing to the evolution of rating systems, frameworks, technical assessments, methodological developments, developing simulations protocols, all aligned with the Indian climatic realities and sustainable goals. Currently, I'm also pursuing my PhD from IIT Roorkee in the field of energy efficiency and sustainability, where the focus area is basically to improve the accuracy in daylighting simulations through the integration of the measured sky luminance data. When I used to pursue my daylighting simulations at my postgrad level, and the moment I had to select a sky condition called the overcast sky scenario, and the results that I used to go get, and the moment when I used to measure it with the on scale real scale lux meter, I used to found a very big difference. And that is where I thought that what is that factor which can ultimately make us lead to a realistic sky visualization, or to achieve the real sense of lux levels, what we actually get on the task and what we actually perceive in our simulations.
Thank you so much for sharing that, sir. That has been definitely a very great journey. I'm sure you must have learned from all these places and universities a lot of depth in the education that they provide. So, you have also been with GRIHA Council for over a decade. Could you share what your current focus areas are at GRIHA?
Okay. So at GRIHA Council, my current responsibilities span across the technical refinements and strategic development of India's green building rating framework, which is GRIHA. I'm actively involved in enhancing the rating variants that addresses a range of building type building types, including your affordable housing segment, industrial developments, commercial infrastructure, which is coming up. So a major area of focus is integration of performance-based daylighting and facade design parameters into the rating criteria, which I specifically look and with the goal of promoting climate responsive and energy efficient design solutions. I also lead the technical evaluations and audit for large scale green buildings projects, ensuring compliance with GRIHA rigorous performance benchmarks. A key part of my roles involves facilitating research collaborations aimed at translating emerging building science into actionable rating metrics, particularly in areas such as thermal comfort, daylighting performance, and envelope optimization. In addition to this, I head the GRIHA product catalog, which is a national level initiative that validates and incorporates green building materials and technologies into the rating ecosystem. Comprehensively, my technical responsibilities, I actively contribute to capacity building programs, conducting workshops and training sessions for architects, engineers, consultants, government bodies to advance the practical applications of GRIHA sustainability standards.
That's a huge scope, and I think there's a lot to learn. And definitely, you're working on something really great. So, I think there's a lot to learn from your experiences. So GRIHA plays a major role in defining how sustainability is understood in the Indian building context. How do you see the role of research, like the kind of work that you're doing in sky modeling and daylight, influence future rating systems?
See, research is a cornerstone in transforming green building rating systems from static rule based frameworks into dynamic performance driven evaluation tools. In the context of India's diverse climate zones, generic international models or codes for sky conditions often fail to represent the actual luminous environment. To address this particular gap, the research basically about the sky modeling has focused extensively on contextual daylighting modeling and classifying of India's sky conditions using real-time measurements. One of the foundational efforts in this direction begin at the Mahindra Terry Center of Excellence, which is located in the Terry campus of Gurgaon, where India's first calibrated sky scanner was installed. This facility enabled continuous measurement of sky luminous distribution, which is a critical step in empirically characterizing the visual sky dome across varying sections and times of the day. The initiative was further expanded in phase two through a collaborative research partnership with Saint Women Research India, leading to the installation of the second scanner in Chennai to represent the coastal climatic conditions. Together, these two locations provide a robust database that forms a backbone of the ongoing research on sky modeling classifications, daylight availability, and climate adaptive simulation techniques. Through these effects, we have successfully classified sky conditions using the actual luminance data based on the 15 CII standard general sky models, representing the earlier reliance on the theoretical assumptions, where business as usual when we used to consider overcast sky scenario for all our analysis. Now, this has directionally informed simulation workflow, improving the accuracy of daylight and energy performance assessment, which is further integrated into the GRIHA rating system. Such empirical research not only enhances the accuracy of daylight simulations, but also helps define region specific performance benchmarks. These insights are instrumental in making rating systems like GRIHA more climate sensitive, scientifically robust, and predictive of the real world building behaviors. Ultimately, the body of work supports a future where green rating systems are underpinned by locally calibrated data, empowering architects and engineers to design buildings that are both environmentally responsive and they are technically optimized.
That's really insightful, sir. Because we are talking about daylighting and the systems around it. Daylighting is usually often talked about as a key sustainability strategy. But when it comes to design, why is it so important for the Indian context?
Okay. So, daylighting in architecture design refers to the international and what do you call optimize use of natural sunlight to illuminate the indoor spaces. Now, thereby reducing dependence on artificial lighting while enhancing occupant comfort and well-being. It involves more than just allowing daylight into a space. It requires a careful balance of light intensity, distribution, glare control, and visual connect to the outdoors. In the Indian context, daylighting assumes particular importance due to the country's diverse climatic condition, ranging from hot, humid, and cold to composite and arid zones. In India, high solar intensity and extended daylighting hours provide immense potential for natural illumination. However, without a climatic sensitive approach, daylighting can lead to challenges such as thermal discomfort, excessive glare, and increased cooling loads. Therefore, daylight design in India must be data informed and simulation driven, accounting for variables such as solar angles, sky conditions, and occupancy patterns. Moreover, daylighting is not just a design aspiration, it is a performance criteria, whereas in the national building codes and the rating systems such as GRIHA, where it is used to evaluate visual comfort, energy efficiency, and envelope performance.
That's a really interesting topic, and I think there's a lot to learn and understand from this, which we can actually apply in design and architecture of the future. You mentioned that you have also worked on a project under the SGRI. Could you help us understand what the study is and what was your role in that?
Okay, so the study at SGRI, Saint Gobain Research India, as I told you, that was under the phase two of the sky modeling activity that we started off in SGRI, and the SGRI study was jointly led by SGRI and Mahindra Tele Center of Excellence. It is actually a landmark initiative aimed at developing a high resolution measured sky luminance data for the Indian climatic conditions, specifically in the coastal belt. So my role in the project basically involved designing a classification algorithm that accurately, mapped the real-time sky data of the 15 CI standard general sky types which are there, and embedding a more context-sensitive and reliable data simulation. Now, the research began with an installation of the India's first calibrated sky scanner in the southern part of the country. After followed with the installation which we had in Gurugram. Now, this was way back in the year 2023 when we installed this sensor, this sky scanner in Chennai. After Delhi, the Delhi installation took place in the year 2020. Now, the project was actually made possible through a strong collaboration. Dr. Karthik Kumar from SGRI, he provided us scientific direction. Ms. Shelley, supported in the administration, the technical coordination. Ms. Anjana from SGRI, she contributed significantly to the automation of the data acquisition and processing the workflow. At Terry, there was a strategic leadership from the directors, Ms. Shabnam Bassi and Ms. ensured that the research, remained aligned with the national sustainability goals and could feed directly into the framework, such as the GRIHA rating system that we have. The study has accumulated into a joint international publication that we will be presenting at the IBIPSA Building Simulations 2025 conference in Brisbane next month, marking a significant milestone in establishing measured daylight data as a foundation for building performance assessment in India.
Sir, this daylight sky model that you mentioned, can you help us understand what it is and how it can improve the accuracy of daylight analysis in the buildings?
Okay. So, the Indian daylight sky model is a location specific adaptation developed using measured sky luminance data that reflects the actual sky condition observed across various Indian cities. So, right now, the two Indian cities that we have captured is Delhi NCR, which is Gurgaon, and second is Chennai, the coastal belt. Now, this measurement that we have taken, this basically feeds a database for roughly 200 kilometers of dia of Delhi NCR and 200 kilometers of a dia of the Chennai region. Now, the more and more scanners that we have in the country would ultimately help us, get a more realistic data of other parts of the country. Specifically, if I look at the eastern and the western part of the country, where we strongly feel that the scanners should be there. Now, unlike the international models that rely on static assumptions of clear sky or overcast skies, this model captures the dynamic nature of intermediate and partly cloudy conditions prevailed in India. And in our research, we found out that that in Delhi and in Chennai, the sky conditions are very similar. Although the distance, the climatic conditions are very diverse, but however, the sky conditions what is shared by both the cities is almost on a very similar pattern. Now, this is a region because they both come on the same latitudinal line. Now, by integrating this model into daylighting simulations, designers can achieve a more accurate prediction of light penetration across the seasons and orientations. This is going to basically help them get to the level of accuracy by more than 35%. This enhanced accuracy plays a very critical role in determining the optimal window to wall ratio that they're selecting, the appropriate glass that they're selecting with a suitable visual light transmission VLT value, and defining the total glass area for their respective project, which is the most important thing. And as a result, it enables the architects and the engineers or the designers to make a better informed decision that balances natural lighting, visual comfort, and energy efficiency. All the three triangles well cumulated, and ultimately leading into a more climate responsive building design.
That's a really interesting study, and I think there's a lot of data and knowledge that we can gain from that as well. So, talking about the sky model as well as the day lighting that we were talking about, uh, how do you think can architects use these to design real projects to earn some credits and some certifications for their own buildings and for their structures?
Okay. So, I'll specifically, talk about GRIHA rating system, which I understand, more. So GRIHA addresses, daylighting and facade design through a focused set of performance-oriented criteria that basically encourage climate-responsive architectural solutions. In GRIHA, we have criteria 11, which is visual comfort, which emphasizes adequate daylight illumination in regularly occupied areas while minimizing glare through design measures. Now, in GRIHA, we have introduced daylighting analysis methods such as UDI, useful daylight illuminance, and daylight autonomy, DA. Now, these two are climate-based daylighting models, which basically require analysis for 365 days for the operating hours of a particular building, depending upon how on what occupancy and what schedules it works. Now, this basically gives you an overall idea that how is your glass going to perform under varied seasons and orientations with your present design. Now, this includes the use of appropriate shading devices also, facade articulation also, and high performance glazing also. So, it is always a mix of, or, a combination of the strategies like, orientation, shading devices, facade articulation, everything, is coming in parallel with each other. So, projects are evaluated through a validated simulations, either UDI or daylight autonomy, whatever, approach that they wish to follow, and based on that the projects are awarded. And one thing is for sure that while following these daylighting metrics, the projects which turn out, they are developed, making sure that they are clear, that there is glare control, which makes a visually comfortable environment for the users. Uh, Not just for the visual comfort side, but glass also plays a very important role for energy efficiency. In GRIHA, we have criteria 14, which talks about building envelope optimization, which promotes the selection of the glass with respect to the VLT, SHGC, and the U value of the glass, which basically determines that what is the total heat integration a particular building is, going to capture from glass. And specifically, if I talk about SHGC, SHGC plays a very, very critical role because that is where your 80% of the direct solar radiations are striking off or striking in for. Uh, So we, ensure that, that you have a effective SHGC, which is basically developed not just with the help of the glass, but integrating shading on top of it to make sure that the glass has a lower SHGC limit, or it behaves as if a lower SHGC high performance glass, making sure that the project cost also gets optimized. Now, by integrating daylighting strategies early in your design processes and aligning them with building orientations and local climate orientations or conditions, the architects can, enhance occupant comforts and reduce the lighting energy demand. And simulation tools like Radiance, ISV, Honeybee, Climate Studio, and there are, multiple other tools, daylighting simulation tools, validated tools, of course, which could play a very critical role in meeting these requirements and demonstrate compliance under GRIHA rating system.
That's really interesting, and I think there's a lot for architects and designers to take from this particular work that you have been doing and the kind of work that is available outside to design their buildings and their future structures as well. So, coming to the topic that we have for this session, we can now start talking about glass and how glass fits into all this. So, when it comes to facades and daylighting, as you mentioned, glass is the key material. How do you see the role of glass in balancing natural light, energy performance, and thermal comfort?
Okay. So, glass plays a pivotal role in facade design by simultaneously, embedding daylight access, visual connectivity, and architectural expression. However, its impact on thermal comfort and energy efficiency or energy performance is highly sensitive to specifications and applications. In the Indian climatic context, where solar intensity is high for most of the year, glass selection must be beyond aesthetics to carefully balance visual light transmissions and solar heat gain coefficient. High performance of or spec or high performance or specularity selective glass can allow ample natural light while minimizing unwanted heat gains, thereby enhancing occupant comfort and reducing dependency on artificial uh, cooling. Now, when integrating thoroughly or thoughtfully, considering the orientation, shading device, and occupancy needs, glass becomes a critical element in achieving both visual comfort and energy efficiency. Its role is not standalone, but rather plays a holistic facade strategy validated through simulations to ensure that daylighting benefits are maximized without compromising thermal comfort or thermal performance. Uh, in in performance driven frameworks and energy conscious design, glass is no longer a passive material but an active environmental interface.
As you mentioned, talking about spectrally selective and high performance glazing glasses, how do you suggest architects and designers approach glass selection in climate responsive buildings, especially if they want to meet the standards of GRIHA?
So, selecting the glazing or the glass for a climate responsive design begins with a clear understanding of the buildings of your building's geographical location, where you are placed. Whether you are in Delhi, whether you are in Chennai, whether you are in Mumbai, whether you are in Guwahati. So it plays the very basic role. Now, the next part is the orientation. Where are you orienting your building? Where are your windows oriented? And the usage pattern. Now, let's have example in composite climates such as Gurgaon, Delhi, Chandigarh. Now, glazing solutions must address the dual challenge of high solar heat gains in summers and the need of effective daylight utilizations throughout the year. Because ideally, in a composite climate zone, during the winter season when it is too cool, you require daylight and you require heat to penetrate into your building. Now, ideally, the glass should have a lower SHGC value to reduce unwanted heat ingression, while meanwhile having a high VLT, to support natural lighting and minimizing reliance on artificial illuminance. Specularity, specularity selective glazing offers a balanced approach by allowing visible light to enter while filtering out the infrared radiations, thereby enhancing both thermal comfort and energy efficiency. The selection process should be supported by simulations, of course, based on certain validations, using tools to analyze the impact of various glazing options on daylight penetrations, glare risk, and indoor temperature conditions specifically. This ensures that glass is not just an aesthetic choice, but an integral component of a building environmental performance strategy.
So, sir, you've had almost 12 to 13 years of experience in this particular field. Have you ever seen some common mistakes or some oversights that designers or architects have made while integrating daylight strategies in facades?
Yeah. So in GRIHA, GRIHA has given me this opportunity to, travel across the country and, to experience, through site visits, buildings pan India, ranging from, every typology of building. So whether it be, a commercial building, whether it be a hospitality building, whether it be a hospital building, educational institutes, housing complexes. So, I've got an opportunity to visit, every typology of building and specifically, in the entire country. So I've, seen a very defined, picture of how the building construction sector has grown and what are the advancements which have been, integrated into the design. Uh, in my past experience of almost, more than 500 plus buildings that I have visited across the country, one of the most common pitfalls in daylight facade integration is the application of uniform glazing across all facades without accounting for orientation, specific solar exposure. Now, for example, east and west facade receive low angle sunlight, now making them more prone to glare and overheat, yet are often glazed with the same specifications as in the north and the south facade, creates a very big problem. Now, another frequent oversight in the is the overuse of high transmittance of glass without adequate shading, leading to visual discomfort and increased cooling loads. Now people feel that if you give a clear glass, it will allow more daylight exposure. At the same time, you will also have a better view. But we forget the concepts of building physics. We completely forget that where are we actually building our project. It is not the northern Scandinavian part of the world where we are. We are very we are near to the equator. Tropic of Cancer is something which passes by us. So we need to understand the geographical location where actually we are. We need to also see that design that prioritizes aesthetics, such as fully glazed facades or reflective glasses, without considering functional performance, often compromising the occupant comfort and leading to higher energy consumption. Now, additionally, neglecting to stimulate the daylight and thermal performance during early design stages results in buildings that either suffer from underlit interiors or excessive solar gains, where you have to provide an air conditioner to exhaust out that that excessive heat that you have accumulated into your building box. Now, a critical mistake is relying solely on the perspective rules or visual impressions rather than performance-based simulations or informed approaches. With thumb rule basics. That okay, that if what is our height, let's consider 2h. As our height, as the distance where the daylight area is going to be perceived. But these are something which were perceived when technological advancements were not there. But right now, when we have them available, then we should effectively use it. And effective daylight integration demands as coordinated and intensive design processes where facade compositions, glazing selection, and shading strategies are evaluated holistically to optimize both comfort and making sure that the energy use is reduced.
That's the discussion that we had. This is actually something that almost all of us have at least experienced once in our lives. Either we have entered a building which is very shady, or there is a building which where we have seen a lot of light. So I think there's a lot to relate from this particular discussion. So you've also worked extensively on refining simulation methods for daylight analysis. How important do you think it is to align simulated performance with real world connections, and how can young designers start exploring these tools?
So, daylight simulation is a very critical part of contemporary design practice, especially, when performance outcomes like daylight access, energy usage, and thermal comfort, visual comfort, must be quantified before the construction. It is very important. Because once a building is constructed and then you find out that okay, the lux levels are very high, the lux levels are very low, then then you try to look at retrofit models, and that is what is where you have failed as an architect. So it is always better to simulate your buildings well in advance with the accurate weather data, your material integration, so that you can better assess your building before it is constructed. uh, However, the reliability of any simulation tool, whether it's Radiance, Taysim, Climate Studio, Ladybug, Honeybee, there are multiple of them. Now depends entirely on the quality and realism of the input data that you provide in them. So if let's say for example, if I enter the wrong input value, I will not get a correct output result. So let's say for example, if 2 plus 2 is 4, and if I enter 2 plus 3, and if I expect the answer to be 4, it will tell me 5. So where is the fault? The calculator is not the fault. My input parameter, my input data entry was at a fault, and that is the reason in result what I have got is incorrect. Now incorporating measured sky luminance data and accurate weather files and realistic material properties such as the reflections, the glazing specifications, it is essential to ensure that the simulation output mirrors real world performance to the best you can. Now one of the most common shortcomings in practice is the use of generic or default values, which can lead to a significant performance gaps. I always encourage especially young professionals, because they are well acquainted with these tools, to treat simulations not as a one time task, but as an iterative design companion, one that evolves with each refinement in the building geometry orientations or with the facade strategies. Now what we eventually do is that we get certain values, we get those default values input into our simulation tool, and then we expect whatever results we have got, that is true, that's the gita. But that is not so the case. So that is where it is the start. Now you have to start refining your design. Now starting with small scale studies and validating outcomes through site observations or monitoring case studies is a very good it's a very good way to build your inculcations and your skills. Now over time, integrating measure data and contextual variables transform simulations from a perspective tool into a design validation framework, ensuring that decision made on paper truly translate into a high performance human centric space.
That's really insightful, sir. There's a lot to learn and there's a lot to take away from that. As you mentioned, designing better and seeing the future and seeing how different people and different departments are pushing for net zero and climate resilient buildings for India. How do you see the role of smart facades and dynamic glass evolving in the Indian market?
Okay, so what I believe, smart glasses or smart facades, they're featuring, dynamic glazing, movable shadings, or sensor-driven, operabilities. Now, they hold an enormous, promise in India, especially in the Indian cities, where climate conditions can shift rapidly, within a single day. Specifically, if I talk about the monsoon season, you'll experience that you have heavy rains for some hours. Now after that there is bright sunshine, After that, there's going to be, there's again going to be, rain. So it's very dynamic. Now, however, there is an uptick in the currently limited. It's currently limited due to the cost, which I believe is quite on the higher side, and the supply chain, because most of the products are imported, which basically increases your carbon footprint, and the limited performance validation under the Indian conditions, because this is something which is gauging up. So there is, we don't have, much data in terms of its behavior, in terms of its, its adaptation to the Indian conditions. The future, will depend on the policy initiatives, deeper integrations into performance-based codes and localized research. As a cost barrier, reducing as a cost barrier, reduce, and simulation protocols become more refined. And I see these, technologies play a major role in institutional and commercial building specifically.
That's really insightful, sir. You have had experiences in a lot of things in the past years, including research, including teaching, and now at GRIHA as well. What is that one lesson or experience that changed the way you think about sustainability in buildings?
So it was, in my early days when I joined Griha, and when I was, on my initial visit. So during one of an audits of a building, I found that despite meeting all the design phase compliances, the actual occupant experience showed, discomfort, and this was due to the poor glare control. So in Griha, whenever we go for final audits, we carry certain instruments with us. Like for light, we have a lux meter. We carry a lux meter with us. We capture humidity levels, temperature levels on the specific work planes. We measure the decibel levels on a specific location. We also measure what is the air quality in terms of CO and CO2 levels on a respective place in the interiors. So when I measured the lux levels on a specific building, this was in Nagpur, I remember, and this was a data center building. And there, the building design was very well. It was a very well designed building. But when I went for the audit, and as soon as I placed the sensor on the work plane, I found the lux levels to be somewhere close to around 400 and 500 lux, which is a decent lux levels. But when I looked around, I found that the blinds were on, like there were blinds, and the artificial light was turned on. And it was because of the artificial light, the person was receiving 300, 400 lux, or 400, 500 lux, sorry, on the task surface. Now, then I, asked the person who was there on that seat that, are you comfortable? Are you visually comfortable sitting and working? So he said, yeah, I'm fine. I said, okay, can I bring a small change, and can I note your, observation to it? So what I did, I turned off the artificial light and I turned the blinds on. And after that, when I measured the lux levels were somewhere close to around 500 lux, very, very close to what were perceived when the artificial light was turned on. Now, at that point of time, I asked the person that, are you comfortable now? He said, no, 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 I'm finding glare on my eyes. That was something which struck me, that with a lot of efforts being in place, the outcome is that the person is not comfortable and is complaining that there is glare, and the entire efforts are gone. Now this highlights the gap between the theoretical compliance and the lived experience. It reinforced my belief that sustainability is not just technically, it is human centric. Building performance must be felt and not just measured.
That is, I think, a very important lesson that one must definitely learn and strive to take much more such initiatives to go ahead and understand what the building is performing like, even after it has been designed and occupied by. So I think it's a great learning for you as well as for us who want to know more about and learn more about such experiences. Along with this, is there any kind of advice that you would like to give to young architects or students who want to work at the intersection of design and sustainability?
Yes, I would definitely, like to specifically, give a message to the young professionals and, the budding architects, designers. I have gotten also opportunity to, interact with a lot of these young minds, or either through, interviewing them for job applications or for internship programs, or, being invited at, universities and colleges for guest lectures. And, what I have, what I've perceived is that that these young minds, they have to you guys, you have to immerse yourself in the building science. You have to understand the thermodynamics. You have to understand the behavior of light and human comfort. Embrace digital tools, but ground them in physical realities. Collaborate across disciplines, and most importantly, test your assumptions. That is the most important thing. Real sustainability lies in making informed trade-offs, not idealized solutions. And systems like GRIHA offer a structured way to apply this knowledge, build credibility, and drive change through the projects. So try to be more acceptable towards to the thoughts, the person in front of you who's there. What does he demand? What does he need? Try to assess that and then design your building.
Thank you so much for sharing that, sir. Finally, what's one emerging idea or innovation in sustainable building design that you're really excited about right now?
Okay, so innovation and sustainability, the most important thing which excite me, and the thing which I am looking forward is the integration of AI, with performance simulation workflows. This is something which I'm looking forward for. This is something which is both promising and complex at the same time. Now, AI, artificial intelligence, can rapidly analyze massive data sets, identifying the patterns, optimize geometries, and proposing the best envelope configuration for you. But it must be used with caution, because without quality data and interceptive oversights, AI can amplify errors. So, I'm optimistic about its role as a design assistant, accelerating decisions and reducing iteration cycles and supporting climate specific solutions when used in synergy with expert knowledge.
This was definitely a very insightful session. From decoding the science of daylight to helping us understand how facade design and material choices, especially glass, play a role in meeting energy and sustainability goals. Today's session was packed with knowledge that bridges research, certification, and real world design. We truly appreciate the depth and clarity you brought to complex topics, and we are certain that everyone watching, whether a student, professional, or educator, has walked away with valuable takeaways. To all our viewers, thank you for tuning into this edition of Glass Academy webinars in collaboration with Ethos Empowers. Stay curious, stay inspired, and we'll see you in the next session. Until then, keep learning and designing a better, brighter, and greener future.